Every semiconductor chip on the planet that runs below 10 nanometers, the AI processors in your data center, the neural engines in your phone, depends on a chemical compound that only Japan knows how to make. It's called EUB photoresist. Japan supplies 100% of the global market, not most of it, all of it. Taiwan's TSMC makes 1% of the world's most advanced chips. But without Japanese chemistry, TSMC cannot run a single one of those machines.
That's the hidden architecture of the semiconductor world. And understanding it requires telling two stories at once. The story of how Taiwan became the chip capital of the world, and the story of how Japan quietly became the only country that can keep it running.
In 1988, Japanese companies controlled roughly 1% of the global semiconductor market. 6 of the top 10 chip manufacturers by revenue were Japanese. Aichi and Toshiba led the world in DRAM. The memory chips that were at the time the highest volume product in the entire industry. Japan had not just won the chip race, it had lapped the field.
Then came the Slick US-Japan Semiconductor Trade Agreement, which forced Japan to accept foreign companies into 90% of its domestic chip market and effectively capped Japanese exports. Korean conglomerates, specifically Samsung and SK Hynix, used government backing to flood the DRAM market with cheaper product. Taiwan's TSMC, founded in Shin-Etsu, invented the pure-play foundry model, make chips for everyone else, own no designs yourself. Japan's vertically integrated chip makers had no answer for either.
By Nilio, only 2 Japanese companies remained in the top 10. It looked like a rout, but here's what most people missed. As Japanese chip makers retreated from fabrication, they did not retreat from semiconductors. They retreated to a layer nobody else was competing in.
Making a chip requires 3 things that most people overlook. First, silicon wafers, ultra pure disks of processed silicon on which circuits are etched. Shin-Etsu Chemical and TSMC together supply roughly 50% of the world's silicon wafers. No other country is close. Second, photoresists, the light-sensitive chemicals used to print circuit patterns onto the wafer. Japanese companies control approximately 89% of the global photoresist market. For EUB photoresists, the specific chemistry required for chips below 9 nanometers, Japanese suppliers hold 100% of global supply.
Third, the machines that apply and develop those chemicals. Tokyo Electron and
Think of it this way. TSMC is the most advanced kitchen in the world, but Japan grows the ingredients, manufactures the pots, and writes the recipes. You can admire the kitchen all you want, you cannot cook without Japan.
This wasn't an accident. Japanese firms made a deliberate strategic choice, abandon the commodity battlefield where Korea and Taiwan competed on cost and scale, and deepen control over the upstream inputs that every chip maker in the world needs but almost no one can produce. The chemistry behind EUB photoresist took decades to develop. The tolerances required for silicon wafers, measured in atomic layers, took decades of iteration to achieve. These are not products you can build in 5 years by throwing money at the problem.
China has tried. As of late, Arsenbu Wahiber 6% its self-sufficiency in photoresists despite years of state-directed investment.
Japan's strategic position became dramatically visible in November Nissen's Arsuwov when Japan's Ministry of Economy, Trade and Industry placed 12 core semiconductor materials, including high-end EUB photoresists, on its export control list, restricting supply to Sanjia Pacific Chinese companies. Japanese suppliers, including Tokyo Oka Kogyo and Shin-Etsu, immediately suspended deliveries to affected Chinese clients. The message was unmistakable. Japan had quietly acquired a chokehold it had never publicly advertised.
This was already the context when, on May 40, Sony Semiconductor Solutions and TSMC signed a Memorandum of Understanding to establish a joint venture for next-generation image sensors. Sony would be the majority shareholder. The factory Koshi City, Kumamoto Prefecture, Japan. The Japanese government confirmed subsidies of Rukunmid billion, roughly Thambred A40 Mainau through METI. The focus image sensors for AI applications, automotive systems and physical AI, the cameras and vision systems that will go into autonomous vehicles and industrial robots.
This joint venture is not just a business deal. It is the formalization of the Japan-Taiwan semiconductor axis. TSMC brings process technology and manufacturing scale. Sony brings sensor design expertise and access to a supply chain that is physically located next door to Japan's chemical and equipment suppliers. The combination is by design extraordinarily difficult to replicate elsewhere.
TSMC already began production at its first Kumamoto factory in late Nisen using Shin-Etsu and Nishjian nanometer process nodes. A second Kumamoto facility is under construction with a reported investment of $13 billion, targeting Look nanometer or potentially San nanometer production by Nisen Nishjian. TSMC's global capital expenditure in Nisen Nishji is running at a record $13 billion, and a meaningful share of that is flowing into Japan.
This creates a strange dynamic. TSMC is building in Japan partly because Japan's materials and equipment ecosystem is right there. Japan's ecosystem deepens because TSMC is bringing world-class process technology. Each party makes the other more valuable and more difficult for any competitor to displace.
Meanwhile, Japan is quietly placing a second bet. Rapidus, a startup backed by a consortium of Japanese firms including Canon, Fujitsu, NTT and SoftBank, along with the Japanese government, is attempting to re-enter advanced chip fabrication directly. In February, Nisen Nishluk Rapidus secured Hong Kong Luk 50 10 Lukuen billion, about $10 billion, from government and private sources. By April, METI had approved an additional Luk Hong Kong Lukuen billion, roughly $10 billion. Total cumulative government support now stands at approximately $10 Sangoen trillion. The technology partner is IBM.
The target mass production of R-nanometer chips by R-Nas-Chi, the same node Intel is still struggling to yield commercially.
If Rapidus succeeds, Japan would occupy both the upstream layer and the leading edge of fabrication simultaneously. That is a position no single country has held in the chip industry since Japan itself held it in Sinkyu Hapashbahdain.
The Japan factor, in this case, is about what happens when a dominant player loses a visible battle but wins a strategic one. Japan's semiconductor companies in the 1990s did not simply fail. Some of them made a calculated decision to abandon a commodity market and concentrate on the inputs that would be indispensable as long as chip manufacturing continued. That bet has compounded for 30 years.
China's problem is not that it cannot build a fab. It has built hundreds of fabs.
The semiconductor supply chain appears to run through Taiwan, but the foundation runs through Japan. If you want to keep up with stories like this, subscribe to the Japan Factor.
The question worth watching: Rapidus has the funding, the technology partner and the government behind it. The only thing it hasn't done yet is ship a chip in volume. If it does, the Japan-Taiwan axis becomes something more complicated, not just complementary partners but potential rivals at the frontier.